Hello friends, I am Dr. Rajesh and today I am back with elliptic orbit. In this lecture we will discuss the center orbit and elliptic orbit is also one of the center orbit, and after elliptic orbit I will place the problem for you for hyperbolic orbit, and the hyperbolic orbit you will do at your own. So in this lecture we will be covering the elliptic orbit. It is very important question from the examination point of view. The problem of elliptic orbit goes something like: a particle moves in an ellipse under a force which is always directed towards its focus, and we have to find the law of force. Number 1, velocity at any point of its path. Number 3, the periodic time. So firstly we shall be calculating the law of the force. We know that equation of ellipse is given by L by R equal to 1 plus E cos theta, where E is eccentricity and E for ellipse is less than 1 and greater than 0, that we have to remember. And eccentricity is given by B square is equal to A square 1 minus E square, where A is greater than B. A is major axis, semi-major axis, and B is semi-minor axis. A is greater than B, and then this formula is used. And L is equal to length of semi latus rectum, which is equal to B square by A. And the figure of the ellipse is something like this one. Here this is the eccentricity AE, the focus, and this distance is R. This is R dash, distances are measured from the focus, and this is any point P, and this is theta. So this will be R comma theta. And you see this is the semi minor axis B, semi major axis A, and here A is greater than B. So equation of the ellipse in polar form is given by equation number 1. So this is the ellipse. Now we move further, and in the earlier articles we have supposed that 1 by R is equal to U. Using this in equation number 1, using in 1, we get LU is equal to 1 plus E cos theta. This implies that U is equal to 1 plus E cos theta by L, named as equation number 2. And we know the differential equation center orbit in polar form is given by U plus d square U d theta square is equal to F by H square U square. You may name it as equation number 3. We will be using this equation. Okay. Now for this we need to determine the double derivative, so I am going to differentiate it with respect to theta. So what will be du by d theta? It is equal to 1 is 0, and it will be minus E sine theta, and L is also constant. Differentiating again, d square U by d theta square is equal to E cos theta by L, and here is the minus sign. So using this in equation number 3, we get plus d square u by d theta square is equal to u is 1 plus e cos theta by L minus e cos theta by L is equal to 1 by L plus e cos theta by L minus e cos theta by L. This will cancel out, is equal to 1 by L. Okay, and this will, when put, this was equal to f by h square u square by 3. This implies that 1 by L is equal to f by h square u square. This further implies that f is equal to h square u square by L. This further implies that f is equal to h square L 1 by r square, because u is equal to 1 by r. This further implies that f is equal to lambda by r square, where lambda is equal to h square by L, that is h square is equal to lambda L. And I am going to this as equation number 4, because I will be using this relation in at later stage. So this implies that where lambda is a constant, because h is constant, L is constant, so this lambda is a constant. This implies that f is inversely proportional to the square of the radius vector, and this is the law of the force. The first thing we have determined the law of the force. Next we need to determine the number 2, velocity. In the previous video where we have discussed the aerial velocity, we have determined the formula for the velocity when its path is known, and it is given by Vp is equal to h when path is known, and here the path is known because path is elliptic. This implies that V is equal to h by p. This implies that V square is equal to h square by p square. This further implies that V square is equal to h square, and we know 1 by p square is 1 by r square plus 1 by r4 dr d theta is whole square, and this is equal to h square. 1 by r square is u square, this will be u4, and dr by d theta, because u is equal to 1 by r, that is r is equal to 1 by u. Dr by d theta will be equal to minus 1 by u square du d theta. So this will be minus 1 by u square du d theta whole square, and this bracket closed. This will be h square u square plus u4 divided by u4 du d theta whole square. This will cancel out, and this is further equal to h square u square plus du d theta whole square. Now substituting these values of u and du by d theta, this is further equal to h square u is 1 plus e cos theta by L, this whole square, plus its derivative minus e sin theta by L whole square, and the bracket closed. This will be h square 1 plus e square cos square theta plus 2 e cos theta upon L square plus e square sine square theta upon L square is equal to h square by L 1 plus e square cos square theta plus sine square theta plus 2e cos theta divided by L. This thing is equal to lambda. 1 L out of this L square is here and 1 L is here, and we have used because h square is equal to lambda L. That is, I think, by equation number 4. By equation 4, this is further written as 1 plus e square plus 2e cos theta upon L, because cos square theta plus sin square theta is 1, and this is by 4, and let me see, yeah, this is by 4. This equation h square is equal to lambda L. Now this can be further written as lambda 1 plus e square by L plus 2e cos theta by L. Now this will be further equal to lambda 1 plus e square by L plus 2e L, and we have to put the value because Lu is equal to 1 plus e cos theta. So this will be Lu minus 1 is equal to cos theta by e. Now substituting that value, Lu minus 1 by e, this e will cancel out, lambda 1 plus e square L plus 2 by L Lu minus 1, which is further equal to 1 plus e square by L plus 2 L Lu minus 2 by L. This is further equal to lambda, this L will cancel out, 2u plus 1 plus e square minus 2 by L. This is further equal to lambda, u is 1 by r plus e square minus 1 by L. Now this thing is further equal to lambda 2 by r plus, I am going to put the value of e square, and you know b square is equal to a square 1 minus e square. This implies that minus b square is equal to a square e square minus 1. This implies that minus b square by a square is equal to e square minus 1. This value will be substituted, and also all L is equal to b square by a. So I am going to substitute both values over here. A square minus 1 is minus b square by a square divided by b square by a. Okay, b square will cancel out, this a will cancel out, so we are left with 2 by r minus 1 by a. This implies that b square is equal to lambda 2 r minus 1 by a, which is the required expression for the velocity. And from here it is very clear that v square is always less than 2 lambda by r, because from this some quantity is being subtracted, so this v square is always less than 2 lambda by r. Sometime in examination this could be asked to prove that v square is less than 2 lambda by r for elliptic orbit. and 5 is also the expression for velocity. So in till now we have described the law of the force and the velocity. Now we will be moving towards the next one, which is the to calculate the periodic time, the third number. Periodic time. Periodic time is time taken to complete one cycle. By definition of aerial velocity, we know that this is always constant h by 2 by definition of aerial velocity. This implies that this thing will always be constant, and when we again, I am going to take the figure of the ellipse again, and this is the figure of the ellipse. Here if we see, to complete this whole cycle, the area traced during that particular time is area of the ellipse, because that particular area will be traced. So in completing a circle, if I say that area traced will be area of the ellipse pi ab, and time taken in that is t, so this will be equal to h by 2. So because we know that area of ellipse is equal to pi ab, and t is the time period that we are interested in. This implies that pi ab upon h 2 is equal to t. This implies that t is equal to 2 pi ab upon h. This further implies that this is equal to 2 pi ab, and this thing is equal to, this is h by 2. So this will be lambda l square root, because we have by equation 4 h square is equal to lambda l. You can check by equation 4 we have this thing. Now this is further equal to 2 pi ab lambda, and l is equal to b square by a. This is 2 pi ab root lambda, and this is b, this is root a. This will cancel out. This is 2 pi a 3 by 2, and this is root lambda. Implies time period is equal to 2 pi a 3 by 2 root lambda. Okay, and name it as equation number 6. Therefore time period, periodic time period, is directly proportional to a raised to the power 3 by 2, where a is the length of the semi-major axis. So thus we have derived the time period also. So in this particular article we have discussed the law of force, velocity, and the time period, which was given in the problem. Next I put before you the problem of hyperbolic orbit, and that you will do at your own, and I will provide you the hint. The problem for a hyperbolic orbit goes something like that. In this we are given a hyperbola, and we again have to find the same three things: law of force, velocity at any point of its path, periodic time. So in this, the minor change that we have to do is that we have to write the equation of the hyperbola, and we know that equation of the hyperbola in polar form is given by L by R is equal to 1 plus E cos theta, where difference is E is greater than 1, and formula used for eccentricity is B square is equal to A square E square minus 1. Here it is E square minus 1, and in ellipse case it was 1 minus E square, and the length of the semi-latus rectum is same, B square by A. So now I am leaving this up to you as an exercise to calculate all these three parameters: law of force, velocity at any point of its path, and periodic time. This is the equation of the hyperbola. Okay, and here E is greater than 1 and E square minus 1 it is used. In the ellipse case it was 1 minus E square. So in today's lecture we have discussed the uh, elliptic orbit and hyperbolic orbit and derived their law of force, velocity at any point of its path, periodic time. And in this lecture I have also given you some exercise, so I expect you to do it at home and complete that exercise. And this question is again, I will say, important from examination point of view. So thank you very much for being with me for the whole of the lecture, and I would request you to just sit at your home, stay at home, stay safe, and keep studying. So this is all that I have for you in this lecture. Thank you very much for bearing with me for whole of the lecture. And if you have liked the lecture, please like, subscribe, share, and comment. Don't forget to comment in the comment section. Thank you very much, and thanks for watching. This is Dr. Rajesh. Thank you very much.